Welcome. Now it's time for Felix's talk. It's going to be a bit shorter, so if you have questions, there will be ample opportunity for that later. And after that, it will be lunch. And as yesterday, it will be in the restaurant on this floor. So I'll leave it to you, Felix.
All right. Thank you for having me. Before I get started, I want to get a quick sense of like what everyone is kind of like working on. Raise your hand. Who of you is a mobile developer? Should be everyone, right? Cool. Who of you does iOS? Raise your hand again. Definitely the majority, like 90% of the room. That's good because this talk is going to be more iOS heavy than Android. And then another question. Raise your hand again. Who of you has built iOS apps for more than 5 years? Half the room. Perfect, perfect. So you all remember the good times. So as you know, iOS development has changed a lot. Over the last 10 years, I've been building iOS apps for a long time now. It changed in like all different aspects. It changed, for example, the number of supported devices. Like back then, there was the iPhone. That's it. Like we were surprised when Apple introduced another screen size. And now we have so many devices to choose from. We used to, not have a dependency manager. CocoaPods was built by the iOS community. Back then, we used Git submodules or even downloaded source code for easy HTTP request. We used to have really long review times, right? Remember, it was more than 2 weeks, and now it's about a day, I believe, right? And same for marketing material. Back in the days, there were 5 screenshots. Now there is 110 per language you support. We used to have full big releases. We manually clicked that button on iTunes Connect. Now we have things like A/B testing. We have remote config systems. We have slow rollouts. We have automatic regression detection, and we did a lot of other things. It used to be mostly Objective C, C++. Now we mix Swift and JavaScript. We throw in all the languages we can. And also, do you remember when we had to use iTunes to install an app on our device? Like, this was really fun, and there was no error message when something went wrong. It was just like couldn't install the app, and it usually was somehow related to code signing or provisioning profiles. So now we have all these fancy tools. We have the new test flight. We have enterprise distribution. Everything is built into Xcode. We have this really cool IDE. We can have slow rollouts now officially on iTunes Connect. So things have changed a lot, and this talk is basically a lot about that and thinking about the future on how we can adapt our iOS development processes to reflect that and leverage the tools we now have and what we can do to be prepared. So what is this talk about? First off, raise your hand. Who of you has heard of 12-factor app? Okay, like 3 people in the room. Cool. So 12-factor is something really cool. It was written by developers of Heroku. Heroku is this basically server as a service kind of thing, server hosting. And it defines best practices on how to build software as a service applications. And it doesn't tell you anything about how to write your code. It tells you about how to structure your code base and how to deploy your changes and how to optimize your processes around that. So over the last, it's actually very popular in the backend developer community, mostly on Ruby on Rails. Everybody refers to 12-factor. So in the last few months, I kind of like took some of these approaches and concepts and applied it to iOS app development. And many of them you can apply one-to-one. Some of them are not applicable, and I kind of like came up with random new ones. And so this is not about actual code. I'm not going to talk about any code patterns or programming language specific stuff. This is all about big picture processes, architecture, and how to deploy changes. And so everything I talk about can be applied to any language. It doesn't matter if you use React Native, if you use Swift or Objective-C. So let's start out with dependencies. We all have them. We all like them. In general, ideally, our build tools should never rely on the implicit existence of system packages. So all your dependencies should be declared as part of your Git repo. So this includes the exact version of your build tools, the exact version of Xcode, the exact version of CocoaPods, the exact version of Fastlane. And why do we do all this? Well, it allows you to retrigger a build that happened 6 months ago, and if it was green back then, it's gonna succeed again now. Like, it is fully reproducible. But that's of course only the ideal state. Realistically, if you go to your Jenkins dashboard and you trigger a build from 6 months ago, it's probably not going to be green. So how can we fix this? Well, front-end and back-end developers are much, much more advanced when it comes to this. They make use of a few principles that we as mobile developers just don't have yet. So in particular, disposable containers. So for those of you who did front-end or back-end stuff, you probably know that like this whole concept is really fascinating. You spawn up a new container and you use that container to run your tests or to run a deployment, and at the end of the run, you just throw it away. And this is really cool because it makes your build systems so much more reliable and reproducible because you have the exact same environment every time you run it. But unfortunately, at least on iOS, we just cannot apply the same principles. Why? Because you cannot run macOS as a container. While you can run Docker on Mac, you can only run Linux machines on it. So without the whole disposable containers for macOS, how can we still apply some of these concepts and get the benefits without doing the whole thing? Well, first off, be explicit about your dependencies. I mean, this goes without saying. Make use of a pod file for your SDKs. Make use of a gem file for your Ruby dependencies like Fastlane and CocoaPods. And if you have JavaScript dependencies, use a package.json. Next up, and this is something I've been thinking a lot about recently, is automating your Xcode installation. Please do not use the Mac App Store to install Xcode. It's a really bad idea. Why is that? Well, you don't define what version of Xcode you're installing. You just get the latest one. And at some point, you're definitely gonna get screwed by the auto update system of macOS, where they just update Xcode for you, and then your build is red suddenly. So instead, go to the Apple Developer Portal and download and install a specific version. Be explicit about it. And if you can, automate your installation using open source tools like Xcode install. Xcode install is an open source tool that allows you to install Xcode from the command line. You just tell it what version to install, and it does all the things for you, including setting up your simulators. And why is this such a big deal? Well, Apple decided it's a good idea to put everything in one big binary called Xcode, meaning this includes not only your IDE you work with, but also your build tools and everything from code signing, packaging up your application, and deploying to the App Store. It's all one big thing. So it is very, very important that you know what version you're running. And since Swift breaks every year, you probably also know the pain of like having different branches where you migrate on one branch and you have this version requirement, and it's all really a big mess. If you automate that and you're explicit about it, you don't have that problem. And one of the core philosophies of Fastlane was always to have information in configuration files, in text files, as part of your Git repo. And I kind of like tried to took that approach to the Xcode version. So I wrote a little bit about a .xcode version file. So somebody in the community already invented that pretty much. I just went and like wrote in more depth about why it's useful and what you can do with it. The Xcode version file is a simple text file, and all it does, it includes a version number. It would just be 8.2, for example. And then any tool, it could be a CI system like Circle or a tool like Fastlane, can pick up that version and use it for whatever they want. The cool thing about it is that if you now create a branch to like, let's say, migrate to the new Swift, you can just change that Xcode version file, and then your CI system would then pick up that version for you. So if you use Fastlane, there is an action that's called, I think it's install Xcode. It would just pick up that file by default if it will find it, and then install Xcode and use that specific Xcode for you. So having all the dependencies clearly defined obviously introduces the big upside that onboarding new developers is a lot easier. Like right now, when you onboard a new developer, you probably spend the day just installing all these tools and dependencies and making sure the first build succeeds. Ideally, again, if we have containers or if we automated everything, you just clone the repo, run maybe 1 or 2 scripts, and it's running. Another principle is config values. So an app's config is everything that changes in between deploys or in different environments. So for example, the difference between an App Store build and a development build. And most apps have that in some form, right? You don't want to test stuff on a production backend. So some example for config values would be API keys or URLs to like backend services, or even remote feature toggles. So it probably goes without saying that you should not have those values as part of your app source code. It is just not code, it is a configuration. So a way to verify that you have a very clear separation of concerns here is to ask yourself, if you were to open source your whole app source code, including the Git history right now, would that cause any issues when it comes to like security and privacy of the application? So API keys are a very obvious example for this. API keys might change. Some API endpoints require you to rotate keys every year. So just like a very hypothetical scenario, what if your app is live? You use an API that requires a new key every year, and you now have to drop support for an old iPhone because you want to use the latest, I don't know, Swift Magic or something, and now you cannot compile for this old target anymore, and now you basically broke the app for millions of users that cannot afford to upgrade their phones. If you install Facebook Messenger on the first iPad that was ever released, it still works. Like you might not be able to see the stories, for example, like Messenger stories, but like it still works. They are able to keep that app running, and that is really impressive. So another thing is A/B tests. A/B tests first started out mostly used by big companies like Facebook and Twitter, and uh, nowadays everybody can make use of it. There are a lot of SDKs available that allow you to implement A/B tests to test out new features. In particular, you can test out features and use it as a slow rollout also to not break anything while you deploy it. And finally, over-the-air updates. I think over-the-air updates for mobile apps are extremely powerful. They allow you to remotely change config values without having to go through the whole App Store approval process. So if something urgent comes up, you can instantly update your app. Because as you know, App Store approval process is not always consistent. Let's say you have an event like this one, you have a conference app, you need to change a value. Boom, suddenly your app gets rejected because of something completely irrelevant to the change. You don't want to be in that situation. Next up, my favorite topic, deployment. It goes without saying that ideally the deployment of your application is 100% automated. There is no reason you should manually have to like compile your application, set up code signing, deal with version numbers. Like all of this should be automated. And all the other engineering fields, I feel like, have this figured out. It's just that iOS is still lagging behind here. And right now, even though there is Fastlane, there is basically no real alternative yet. Like there's almost no innovation happening in that field. And I hope that's going to change over the next few years. In particular, Apple just announced the App Store Connect API at the last WWDC, and Google Play introduced new APIs also at the last Google I/O. So I do believe there is going to be more innovation. In the beginning, I wanted to talk about those new APIs here in this talk, but turns out it's not yet end of summer, so it's not launched yet. So the cool thing about this, if you automate the whole process, it means that all the documentation on how the deployment works moves from one person's brain on like, oh, this is what I do every time we ship, or move it from a Google Doc to actual source code. You have the configuration. The configuration includes everything needed to deploy. So you have that knowledge in version control. And again, this is a really powerful thing. So ideally, as mentioned before, we would spawn up a container for our deployment. That container would be fresh, has all the dependencies we need, and just push things up from there. But since we cannot do that, most companies nowadays use a centralized machine. So they have, let's say, one Jenkins Mac Mini somewhere in their office. I know, very professional, and it has some kind of automatic Xcode installation, and this is where you deploy from. Why is that a good idea? Well, it very clearly separates the actual deployment, and it shouldn't run on a developer's machine. It should run on a centralized machine that's somewhere remote. So, which kind of like brings me to the next thing. As an employee, there is no reason an engineer should have access to the Apple ID of your production apps. All these processes should be automated. You should have clearly defined rules that deal with provisioning profiles, that deal with app entitlements, and so on. And once everything is automated, when it comes to the deployment, it means that you can deploy from any macOS-based machine. You clone your repo, you run a script to set up your machine, and you can run deployment from there. It doesn't matter where you run it anymore. And another concept that became more popular over the last 4 years are release trains. Release trains are a very simple concept. It basically means that on a fixed schedule, a release train leaves with whatever is in the current branch. So one common example is we ship a new update to the App Store every Friday at 4 p.m. Of the code that's in master. And what is the requirement for release trains to work? Well, your deployment has to be automated. So, app versioning. App versioning is a solved problem. But just to go over the basics, on iOS, each build is uniquely identified by the version number and the build number. The version number is the marketing version. That's the one that your user sees in the App Store. And usually it's fine to have a 2.0 even though it's not a breaking change, because this is not semantic versioning. It doesn't have to be semantic versioning. And the build number is really just an incrementing number. Apple doesn't really care. It just has to change. So again, app versioning is a solved problem. And unless you work in a very small team, I would strongly recommend not to deal with all this manually. There is a built-in tool that's called AGV tool. It's a command line utility that's built into Xcode that allows you to increment each version, and it does a lot of the magic for you around incrementing according to semantic versioning or not. And if you use Fastlane, there are built-in actions that use AGV tool, but make it a little easier to use, so you can use it as part of your fast file. Screenshots, another favorite topic of mine. Raise your hand, who of you here, of these iOS developers in this room, had to create screenshots manually themselves? Almost everyone, beautiful. So I don't have to go into detail on why it is a pain, because you probably experienced it. But just to summarize some of the key aspects here is that you have to generate new screenshots every time you change the design of your application. You have to take new screenshots every time you add support for a new language, every time there's a new device. And you also probably want to optimize your content, your screenshots, your marketing screenshots for each region your app is selling. So if you support the Chinese market, obviously you want the screenshots to be in Chinese, but you might also want to show different content that's more relevant for that particular target group. So another thing that's really hard to get right are the small details. Like for example, if you have an app like Dropbox, you have the last modified date in the list. So what many apps then do is they prepare a dummy account once a few years ago, and then if you look at the screenshot, it says last modified 3 years ago. You probably want to show a more realistic example where it said last modified a few hours ago by Matt. So these are all things you can fake very easily once you automate it. If it's not automated, you're going to waste a lot of time every time you create new screenshots. So many of you probably know Fastlane Snapshot. Fastlane Snapshot is actually a very simple tool. It uses UI tests, which are built into Xcode, to navigate in your application. And what Fastlane Snapshot really does is it just calls UI tests that navigates in your app and takes the screenshots, but it runs it on all the devices and all the languages your app supports. So you don't have to do any of that manually, and it prepares all the screenshots in the right format so you can upload it straight to App Store Connect. So similarly to containers, I always recommend to clear out all the simulators you have and generate new ones on each run. Your setup should prepare the simulators in a way that it adds all the dependencies, for example, fake files or fake photos, on the simulator for you. So you always know that it works reliably, no matter if you have an internet connection or if the simulator is set up. So obviously you usually want to create the screenshots to upload them to the App Store. Thanks to the App Store Connect API, it's going to be even easier, but for now you can use Fastlane Deliver to upload it to there. So one thing I really love about Fastlane Snapshot is that it forces you to support better accessibility. Why? UI test uses accessibility labels to find buttons and navigate with them. So it actually is always a great reminder, because if you want to take a screenshot of a page that you don't reach without accessibility, with just accessibility, that means your users also cannot reach that page. So it always forces you to add accessibility support for every new feature that you want to cover. So And finally, another thing is that at the end of each run for Fastlane Snapshot, you get a really nice summary that's basically thousands of screenshots for each language and each device type you support. And what's great about it is that you can see that, for example, if you have a German app, if your app supports German and you have the cancel button, it's called abbrechen. So if it's an iPhone 4, most likely it's going to break the user interface of your app. So you can very easily find those things because you get this overview for all the languages, all the screens, and all the devices. So, code signing. Nobody's shocked. It's Halloween, right? So we used to have this really cool button in Xcode. It was called Fix Issue. Again, these were the good times in iOS. We don't have that anymore. It's just renamed and it's the same thing still. But for small teams, it's usually fine to just like let Xcode do its thing. So the way Xcode handles code signing is if you let Xcode handle code signing, it would just see if there is already an existing private key. If there is, it's just going to revoke it and create a new one. So if you have two members in a team and you click fix issue, or now it's called differently, but it's the same thing, it would just revoke each other's keys all the time and regenerate new ones. And it kind of works, obviously, but it's not really an ideal solution. So once you are a little more professional and you want to have like an actual setup that works, you will have to implement some kind of syncing of private keys. So Apple doesn't hold your private keys. So you're responsible for transferring the private key from one Mac to all the other Macs that need to be able to code sign. For distribution, it's easier once you have a centralized CI machine, a centralized deployment machine, because then the private key is only on that machine, right? But if you want to have development certificates and you want to have them on the device, you will have to sync them. So you can build a syncing mechanism yourself pretty easily, right? It's just storing a private key in Git. But turns out it's actually a little more complex than that, because you have the dependencies between the private keys, the certificate, the provisioning profile. And every time you change the app ID, it actually revokes the provisioning profile. And so, for example, if you enable push notifications or if you enable iCloud entitlements, it's going to revoke the profile. So stuff like that is going to be really hard to debug. So if you want to make your life a little easier, I would recommend using Fastlane Match. Fastlane Match will take care of all these things for you, like making sure that the profile is actually valid before trying to use it. So Fastlane Match will use a Git repo to sync the private keys and provisioning profiles across your Mac and encrypts then using OpenSSL on top of that. And with the Git repo, the nice thing is you have the whole history, as well as you get to use access control, which you already have set up at your company probably. So you just give access to people you actually want to give them access to. So I was just talking about storing private keys in Git. Turns out many companies don't like that. And usually they say, oh, for security reasons, we cannot store the private keys in Git. So I would just be like, oh, okay, yeah, I get that. So what are you doing instead? And well, they usually tell me they just send it via email, which, as you know, is like not encrypted at all, does not scale at all. And so basically, I recommend please do not use emails for your private keys. It doesn't scale, it's not a good solution, and it would not solve any of the problems. We're actually working on a new system now, so you don't have to use Git, but you can use Google Cloud key storage. So it's actually encrypted on Google Cloud, a service that is designed to actually store secrets. So this will be able to hold your private keys for you, and you don't have to use Git anymore. That was all about iOS processes. You can find the written documentation about a lot of the things I talked about on iosfactor.com. iosfactor.com is an open source project. It's all written in Markdown, and the cool thing is it's also translated to 5 or 6 languages now. So you can contribute new factors if you have ideas. And yeah, you can find more information over there. Thank you.